Okay, thank you guys so much for joining me to focus on place value with multi-digit place value. And please, if you have anything to share or interject at any time, please feel free to do so. We're better together, and I always learn when I am here with you. So this is me in a picture I took at the KCM conference. And there's how you can contact me. If you have any questions or comments, concerns, you're always welcome to contact me at any time. And here's just a little bit about me. Of course, there's my beautiful family, my sweet daughter-in-law, Jessica. If I could have picked a girl for my son, it would have been Jessica, and she's a nurse on the front lines of fighting the COVID virus right now. So keep her and all of our healthcare providers in your thoughts there. And she's married to my wonderful son there. His name is Janna, and he is a math high school algebra teacher in Evansville, Indiana. And then my sweet little hot mess, Asher, there in the middle. He's 4, and he's in preschool and enjoying his life here at home. And the next picture is my partner in crime for 17 years. I was a teacher at Niagara Elementary School here in Henderson County, and miss her dearly, but I love my new position here at KCM, and you can see at the bottom all my new peeps here in Western Kentucky that I get to work with every day, and loving it and living the good life doing that. So great. Here's our KCM website. If you found us, then you've probably been here, but if you might not know all the amazing things that are on here, every professional learning event that we have and our amazing resources, stuff, our annual conference, things about us. If you haven't checked out all parts of that website, please do so. There's the Kentucky Numeracy Project on there that has all kinds of amazing resources. Okay, so let's get into it. Our agenda for today, we're going to be looking at the standards, of course, and the research behind multi-digit place value, talking about physical representations, online learning resources, Desmos and Estimation 180, talking a little bit about counting collections and numbers around us, and then a print resource that I created for a place value game and some arrow cards to accompany that. Okay, so our standards that we're going to be focusing on, there's many, many standards for multi-digit place value, but the ones that we're going to focus on today are from 4th grade, but applicable to 3rd grade, 5th grade, all different grade levels. We're going to be talking about recognizing in a multi-digit whole number, a digit in one place represents 10 times what it represents in the place to its right, which can be really confusing for kids. Representing and comparing multi-digit whole numbers, reading and writing the numbers using our base 10 system, and comparing those numbers using symbols. And then a little bit about place value understanding to round multi-digit whole numbers to any place. Okay, so I found this representation, this graphic, on the NCTM website, but it's also in the Vanderwall book. If you don't have the Vanderwall book, I highly recommend that you get that and read it. It's got great resources in it. And it reminded me of the graphic we use so much when we talk about the 3 aspects of number. So at the top, we're talking about quantity. We're talking about what our place value looks like, what it means. So when we're talking about 32, how can we manipulate it? How can we touch it, represent it, know what those numbers mean? How can we re-represent it to mean 2 10s and 12 1s? So the very, very top of that graphic is talking about the quantity. And then to support that, you go down to the symbolic, which is the written number. And the way that we write our numbers with the 1s on the right and 10s to the left, we have to coordinate that with visual representations so that it makes sense to kids. I think sometimes we jump into that symbolic way too fast, and kids don't really understand what those those digits and numerals mean. And then to support the symbolic, we have the oral part of number, and that's how we say them. And language is so important in supporting learning place value. And we have to be really intentional in how we talk about numbers. I know that, Sloan, one of your pet peeves is using the and when we're not supposed to use and, like 302, instead of saying 302, because that and is left for the decimal. And just things like that, being really intentional about how you talk about numbers. And in that representation of 32, instead of just saying 3, because that could be confusing for kids, but to say 3 tens or 30, so that they get that place value even with how you say the numbers. And one of our goals for today is to think about the multiplicative structure of the number system should be generalized. That is, 10 in any position makes a single thing or group in the next position. The oral and written patterns for numbers in 3 digits are duplicated in a clever way for every 3 digits to the left. But the research that I read said that you can't assume that because kids get that 1, 10s, and hundreds, they're going to be able to transfer that into the next period in the place value. And that's where they get into a little bit of trouble. It's not having enough experiences with those bigger numbers, because it's easy to get out the place value blocks and the sticks and everything for the smaller numbers. So we really have to think about ways to support that learning. And one way to support that is with representations and being very intentional with our conceptual drawings and models. Okay, and thinking about our models, thinking about whether we want proportional models or groupable models or pre-grouped models, because they all serve a different purpose in what we want our kids to understand. Okay, so when we are looking at how we are going to structure our lessons, thinking about the standards for mathematical practice, and I read this great article, and if you're an NCTM member, I strongly represent you go look up Facilitating Mathematical Practices Through Visual Representation, and that's from the Teaching Children's Mathematics Journal. And I would have shared it, except I don't have copyright to do that. But this figure is from that, and it's discussing ideas and representing them during the problem-solving process. And we've talked about that so much, how we need to introduce problems inside of problem solving and not just bare. So when we start with the math problem, we give representations to help students make sense of that problem using the standards for mathematical practice, and then that leads to a better understanding of the solution and concepts and the processes. And the other graphic there on the right talks about the mathematical practices and how using models and representations support those. So when students are making sense of problems and persevering in solving them, a good representation helps them make sense of the problem and make the problem clearer. And when they're reasoning abstractly and quantitatively, a good representation helps them not only think about the context that they're in, but to relate it to other things that they're more familiar with. And then when they're constructing their arguments, making mathematical relationships in the problem visible to help construct those arguments. There's nothing more powerful than being able to represent a problem when you're trying to prove your point or when you're trying to refute someone else's idea. And then of course, modeling with math. You're going to be representing the mathematical relationships, and it's all about the relationships, especially with place value. And using the appropriate tools strategically, choosing the appropriate representation, because there's all kinds of ways to show place value in different kinds of problems, but choosing the one that makes the most sense and relates best to your problem. And then attending to precision is helping you check your answers and make the math visible. And looking and making use of structure, because place value is definitely all about a structure. And then regularity and repeated reasoning. you can use models in a good representation to show those different kinds of things. So base 10 models, they don't show the kids that relationship of 1 is 10 more, but by using all those different models, those kids are able to construct that meaning all on their own. And when I started this PD, I was thinking, well, with really large numbers, how can you put your hands on those really big numbers and manipulate them? And so as I was looking through the Van de Waal book, he was talking about using just visualization for the place value blocks. And of course, I like literature, and I know a lot of you like to use a lot of literature in your math lessons, and thinking about how much is a million. And every time I ask my little boy, how much do you think that is? Well, it's 452,000. You know, he just comes up with some crazy number because he doesn't have that relationship to what a million looks like or what a million is. And I made this little chart, and you can see that I started off with my unit cube, and then those 10 units make that 10 strip, and those 10 strips make that hundreds square, and then that 100 square goes on to make the cube. The 10 hundreds make 1,000, and then we're going to take 10 of those thousands and make 10,000. Do you know how hard it was to come up with 10,000 cubes? I asked all my teacher friends, and nobody had 10 of them. At most, they might have had 1 as a demonstration cube. So I thought that was interesting. But place value at its core is a multiplicative relationship. The capacity to reason and scale about creating units of units and coordinating the units as they transform, and thinking simultaneously all about those attributes of place value and the numerical operation of multiplication. So as I was thinking about the 10,000s make 10,000, so I have 10,000 cubes there. But then to make the 100,000s, I used some PVC pipe there, and you can see that 10 of those 1,000 blocks 10 times would fit inside that 100,000 square. And you can see Asher there holding the square, because have you ever held what that 10,000 square would look like? And you can see in the pattern there that it's going cube to a long rectangular prism to a square to a cube to a long rectangular prism to a square. So if I were to ask you to think about what a million would look like, first of all, you probably are able to consider what shape it's going to be. But did you think I'd be able to sit inside of it? So there is our million cube, and my quarantine crew here, we had a good time making this. To think about, there is a million little cubes inside of there, and then we could fit 10 of those 100,000 squares inside of that. So we actually could hold a million, and I thought that was a really powerful lesson for my kids, and I even have high school kids here, so for them to see and to think about. Okay, so my good friend Janna Archer at South Marshall Elementary, she's an amazing MIT, and she does such a great job with place value. And she uses these because sticks and bundles are phenomenal, I think. They're proportional, you can group them, so I think that they're great for using in place value learning. So what she does is when she gets to that hundreds, she puts them in a Ziploc bag, because you should see the kids when they want to unbundle, opening that bag and dumping them out to see how many tens are inside that 100. Well, the same thing for the 1,000. She's got all those bundles of hundreds or baggies of hundreds inside of there, and you can dump those out and see how many hundreds are in there. And you could just keep on continuing with the huge bag of Ziplocs to kind of get a visual representation of what those larger numbers are. So being able to recognize and generate those equivalent representations of the same number are going to help students when they're estimating and comparing and computing And it's that flexibility that we're looking for when kids are working with numbers. And that flexibility in dealing with numbers will enable students to generate representations that best fit the situation and make their work easier, because that's what we want and what they want too. Okay, so sometimes we might want to use virtual manipulatives, and if you Google virtual place value blocks, you're going to come up with numerous different types, but I chose these two specifically because of this one with the number line. The number line is a great tool, a great representation to use for estimating and rounding. And I especially liked this one because you can change the scale here. Can you guys, if you can't see, I can't see the chat, so if you can't see when I move to a website, please let me know. Okay, so you can
see
change.
it. It's great. Yeah.
Okay, good. I'm so glad. You just chime in and let me know if I move to something you can't see. Okay, so you can change the whole number, and I like this one because you can go to larger numbers. And when you get into decimals tomorrow and fractions in the next few weeks, you can continue to think of this number line. You can choose whole numbers. You can choose your scale. So let's say we wanted to, our scale to be by tens, and we wanted to start at 8,000. And then here's our number line that we can look at. And there's all different kinds of things that you can do. You can look at the jumps and see and do different scales of the jumps. And you can look at the number and see, okay, 8,160, if I were going to round that, which one is it closest to? And that's how a number line can really be a powerful tool to help you when you are when you want to do estimating and rounding. Oh, let me move that. All right. And then, of course, these have place value blocks, and this one also has number lines too, where you can go in and build the number virtually if you don't happen to have all those manipulatives to use, or if you're at home learning and you don't have those manipulatives. Okay, then one of my new favorite things, and I am by no means a Desmos expert, but from what I've been playing with it, I think it's a great resource. And it's pretty easy to make even your own lessons, but it does have some pre-made lessons on it. So we're going to look at the place value multi-digit whole numbers, and this one was already created. And when we get in here, we're going to be in just the preview kind of setting. And it's got a teacher's guide included that you can go through and do some pre-planning and some possible questions you might ask students. When you get on the teacher side of it, you can take a snapshot of what the kids are doing, and you know that one of our things that we do is our favorite no or our favorite yes, and you can show the work that the kids have been doing and have a discussion about it. You can stop kids if you are doing it live, you could stop kids and say, oh, hold on and let's talk about what you're doing. So I think it's just a really interesting and neat program to use. But this one's already pre-made, and we'll just do a student preview here. And for this one, you're going to use the number, I'm going to move some stuff here. You show the number 1,372 and use the slider to put these place value blocks where they need to go. So you just press that and it slides. And then you think about where it needs to go and you build that number. Then I thought this one was a great question to ask. Show 9 hundreds, 9 tens, and 12 ones, because that's reconstructing those numbers and thinking about, well, if I have 9 tens and 12 ones, what might that look like, and change my number. And then, of course, writing it in standard form. Once you have written the number, I think it was 1,000, and then you can share it with the class, and other students' responses will show up here. So you can think about, oh, well, my friend Sam wrote this and mine is different. How do ours compare? And of course, write a number in which the 7 is 100 times more than 472. So kind of thinking about that. And then I love the aspect that not only they type it, 100 times 472, 7,890. And then you can share it with the class, and you'll see more pop up there. So it has that interaction that a lot of the kids are missing right now. And just continues on asking different questions. I like this one especially because you can group the numbers so that the 9 in each number has the same value. So they're evaluating all these different numbers and grouping them. And it's got some more typing of the expanded form. Write the number in 2 different ways. And continue, a vertical number line, which is great to use, 57. So you're really having to think there about where that 57 is going to have to go, and is it closer to 50 or 60? So you're doing that rounding and estimating there, rounding. And use a slider to help you round the number 44 to the nearest 10. So you're thinking about 44 and where it's going to be, and actually manipulating that representation. And it's easy to see, oh, it's a little closer to 40 if that's what you're rounding to.
Bonnie, lots of people are saying in the chat how much they love the fact that you've incorporated vertical number lines. There's
absolutely
probably 5 or 6 little references with it for that. Great.
Fantastic. I think you got multiple ways to represent those numbers. Vertical number line is great. And then here's a horizontal number line. I'm still using those 2. Different representation there. So all of those different ways to meet the standards there virtually. And the other is just a 3-digit place value sort, and I wanted to show you that one because it's a little bit different. I love this part where it says share with their little picture, like turn and share with your partner, and that could be somebody in your home. This has multiple representations. It has the place value blocks, word form, expanded form, standard form, where they're sorting those. And then after they sort, they're going to talk to somebody about it so that they get that discourse. And then the same thing again is sorting the cards, and then showing 327 as many ways as possible, having that open-ended question, not just use these place value blocks to show it this way, but open it up. There's lots of different ways to show 327. And then sharing those with your partner. And then the challenge of creating a 3-digit place value problem on their own. Okay, great. So there is Desmos. And like I said, you can even go in and create your own, and it's not too hard to do. I've been playing with it a little bit. Okay, in looking at Desmos, Estimation 180, if you're not familiar with this website, I encourage you to go to it. This is a great way to make those large numbers visible to students. And he is Andrew Stadel, I think is how you say his last name. He is working with Desmos to put some of his Estimation 180 lessons onto Desmos. He has one on there right now about ketchup packets. That's very fun, and any grade level would enjoy using that, because how many ketchup packets does it take to fill one of those little cups? So starting that discourse, it makes it more interactive. So this is just a quote from him. It says, "Not using visuals in math class prevented students' access to math conversations. Visual math landscapes are an invitation for both students and teachers to enjoy learning math together." So if you go to his website, he has countless different estimation activities for you. So this one is about cheese balls, and he's asking you how many cheese balls come in the container. And he's going to go through revealing the answer, and you get to see those big numbers come to life and become real to the students. But in the interest of time, I won't go to that website, but I do encourage you to go to it and check out all the different kinds of resources he has on there and the different estimations, because it is hard for kids to wrap their heads around how many cheese balls would be reasonable to be in that container. Okay, and then counting collections. We've talked about that before, and our little ones we encourage counting with our little ones a lot. But thank you, Julie, for letting me use a picture of your son there. He's counting, I think they're Nerf gun things, counting a collection there, and it's all in the way they organize and the way they record their counts. You can see that picture from students who are counting collections of buttons, and it's within the record of how they're thinking. You can see if they're multiplicative thinkers, if they're still unitary thinkers, counting one by one, to get their heads wrapped around those big, huge, large numbers. So the benefits of counting collections, everyone has an entry point. You can count in some way, and it's easy to differentiate based on interest or the needs, and it's in how they record their thinking that you're going to see into their mathematical mind. And it provides that window of thinking of students. And the students are building their number sense. Well, is it more efficient to count by tens? Is it more efficient to group into groups of hundreds? What is a good way for me to be counting this collection? And that's how they learn how to write and build larger numbers and develop that multiplicative reasoning and compare their quantities and grow their estimation skills and build that computational fluency, all by counting those collections. And of course, it addresses all the standards for mathematical practice there. And then just encouraging your students and your parents to be thinking about the numbers around you, because there are numbers everywhere, and it doesn't have to be a set lesson plan. Just notice the numbers around you. Of course, toilet paper right now is kind of a timely thing that we're thinking about. And you could talk about, man, think about the way everybody hoarded all that toilet paper. Well, I looked up these facts for real on Google, and it says consumers use about 10 sheets every time they go to the bathroom. And you can talk about how many uses are we going to get out of this one roll of toilet paper. And if I buy a case of them, how many sheets are going to be in that case? And how many uses are we going to get out of that? And if an average person uses 50 sheets of toilet paper a day, how long is this roll going to last? And you're going to see that people are going to have those cases and cases of toilet paper from now until the end of time, because they just didn't need that many. But that's how kids can wrap their head around those big numbers. Okay, and NCTM has this great game that you can use whole group with your students, and I took it and I adapted it for print use. And let me see if I can get over to my oops. Did I turn my video off? Somebody tell me if I turned my video off there.
You did.
Okay, is it back on now? Because now everything's gone.
You're okay. You're back on that slide. Go ahead and keep talking.
Okay, so you can see my slide there.
I can.
Okay, great. All right, so we'll just talk about the game there. Apparently my dot camera does not like to go with Zoom. So we'll just talk about basically what you'll do is you have arrow cards. And I bet if I stop sharing, you can just see me.
You're just seeing your Zoom screen now.
How about now? Do you see me?
Yeah,
okay.
I can see you.
So you're going to get this game board, and what you do, and the reason I stopped that is because I really wanted you to see the arrow cards. And Sloan and the Grace girls did a great job of showing arrow cards yesterday, but these are going up to the 100,000th place. And what you do, Sloan and Brandy, what you do is you just have, like, this is going to be the 400,000. And as you're building your numbers, then the thousands place lays right on top of it, and now you have 49,000. And just continuing on with all the places until you make your number. And what you do is you have your two partners, and they each make a number using the arrow cards, and then you're going to spin the spinner. And this spinner landed on 4, and this person's amount that they're going to get for spinning a 4, they just get 400 points. But this person's going to get 4,000 points because that's where their place value is. And then you continue on spinning the numbers for each round and getting a total. And whoever has the greatest total there at the end is the winner. Let's see if I can share my screen now. Nope, my share screen is gone. So basically that's it. Let's see if I can get my share screen back on. I apologize. I should have known better than to go and do that part of it.
Bonnie, I love the idea of using the larger number arrow cards. I don't actually have those. I just work with up to 3rd grade, but that would be such a great tool when you're building on those.
I agree, and it's so hard to find anything that you can get to use those larger numbers, and I think the arrow cards do a great job of showing the place, the value, and all of those different things. So now am I back on? Okay,
Back
great.
on.
Good. So tomorrow you are going to be learning place value of decimals with the amazing Lisa Riggs. And all the other ones, if you haven't had a chance to log on and see the other ones, go back and check those out. And then visit our website for your one-stop shop virtual everything. Go on there and check that out. And then that's me, and it's my Bitmoji that I wish I really looked like. She needs like a big gray stripe right here and eyebrows growing together because the struggle is real there. And that's just how you contact me if you need any more information.
Bonnie, thank you so much. I am in love with the millions PVC cube that you create. It caused quite a buzz in the chat. You didn't get to see it, but that caused quite a buzz in the chat. So one of the things that people were asking were for some of the dimensions with regards to that. How exciting that you did that. I need you to know that Bonnie always goes above and beyond when she's doing her presentations, and that was amazing. So thank you for technology tools. When we're thinking about those multi-digit numbers, and we realize that going into thousands and 10,000s, our base 10 blocks, kind of are limited in that. So Bonnie showed us arrow cards, Bonnie showed us technology tools, and it's fantastic. This is the time that we thank Bonnie for the great job that she did. And so if you would like to unmute and give her a shout out, what was one of your favorite parts of what she showed today?
I like the Desmos because I've seen Desmos for middle school and high school. I did not realize there was an elementary version. I want to see if it can work virtually because I have a 2nd grader. Right now, that 3-digit place value, if I could play with that and get her to interact with that, that would be awesome.
Great. Yeah, that would be great. Thank you for everything everybody's saying in the chat box. I appreciate it.
Yeah, I was going to say, can you see it now? Yeah, I was going to say, they really say what great resources you gave us, amazing ideas.
And it costs about $5 to make that cube. that's all. So
I said, Home Depot's going to be busy. Lots of L joints and lots of PVC pipe. Because
yeah.
perfect thing to do so that you can have that going back to your classroom. I do want to tell you that Cindy Aussie sent a wreck and wreck, 100 wreck and wreck that was made with pool noodles and PVC pipe also. So this might be the time that we go to do some of that exciting stuff. So from the Kentucky Center for Mathematics, we want to thank you for joining us every afternoon. Tomorrow we are continuing our deep dive into place value with Desmos, and so we'll see you tomorrow. Thanks.